Welcome to FP Mobile in Kotlin Multi-Platform, FP being functional programming. This is a new approach. All the other videos that I've done before this have been long, raw recordings of work in progress. They run for hours and they can be quite tedious and full of lots of rants from me. So whoever's watched them, I doubt many people have watched them very far through. But I'm going to take a new approach. Instead of recording all my raw programming, we're going to do this as a summary after the fact. So I just made a video that was about 3 hours long, and yeah, it was pretty bad. And so for both anyone watching as well as myself, what I'm going to do is after hours of work, make these summaries, which helps refresh my brain the next time I come back to the task. I can just watch the video and see what I did last time around. And this is for Rehearsal Pro. I am the maintainer of the code as well as writing. I did not write the original code in iOS app. For those of you that are new here, it's written half in Objective-C, half in Swift. And it's in the process of being ported or rewritten or ported, I guess you could say, matching the same feature set on the Android side using Kotlin Multi-Platform by gradually rewriting improvements or writing new improvements in Kotlin while I add features and fix bugs and start to build up the Android version. And this has been going on for a while. I've been working on it part-time and planning on ramping up to work on it a lot more full-time now. So you should see many of these summary videos coming your way. So what did I struggle with? For those of you who watched the previous long, drawn-out raw recordings, you may have a little bit of context, but assuming you don't, I'm going to try to bring us back to where we were. I've been working on a long task to fix a bug, and I've been working on it crazily for months because I've decided to do a major rewrite of a portion of the legacy code into a new approach that will be platform independent, meaning it's written ideally in Kotlin, and I'll go over that a little bit now. And what feature are we talking about? Well, in Rehearsal Pro, which is software for actors to rehearse, we have a feature inside scripts. You download, you basically put scripts that you're working on in the app, and they're stored in the back end as well as locally on your device. Most of the users are using iPhones, some use iPads. Here I'm emulating the latest and greatest iPhone 15. Since I don't have the latest and greatest, this is the iPhone 15 Pro Max. So it's got a huge display. It's running the newest version of Android. Well, not quite the newest. It's 17.2. Sorry, Android, iOS. There's a 17.4 release. I need to get up to speed on that because I think there's some users have had issues with it. But the main task that I've been working on is when we go into scripts, we have a feature in here called line sets. And what a line set is, when you're rehearsing, you record yourself saying some of your lines, and you can record it as a line set. It records the voice. And then you can actually share this with other users and practice back and forth and rehearse with other people. I'm not going to go deep into details of that, but there's been some issues with when this goes through a mode in which we share with another user. In fact, this is an example of a script that's gone back and forth between myself and David, the creator of the app. And what happens is that if somebody renames one of their line sets in here, it ends up becoming duplicated on the other side. Actually, I think this will play. Let's see. Tap anywhere to play the first line.
What do we got?
Okay, yeah, and then it's kind of choking because I'm in the middle of rewriting this feature. So that's not the problem. The problem isn't that the line set itself doesn't play. The problem was actually quite trivial. Well, I guess it's not trivial depending on the point of view of the user. But the problem was that if you were to go in here and you were, whoops, sorry, let's go back. That's interesting. Okay, so we go to the line set. Let's take an example lines. So these are line sets, which is a collection of lines. If I go to edit and I rename one of these, So let's just rename this. Well, it's not going to work because I've broken this. But if you were to rename it using the app normally, say line 3A, because the local storage of the line set is replicated with the back end for long-term persistence for the users, you would get a duplicate. So it's kind of a known gaming. You might know this is a duping problem. And so in the process of trying to solve this problem, two things. One, there's some issues in general with the replication system. They call it synchronization in here. So if we look at legacy code, if we look under Swift, now remember half of the legacy application here is written in Objective-C, and half of it's written in Swift. And I've inherited this app to continue the development and maintenance. So on this Swift version here, there is a synchronizers. These synchronizers, they pull the back end periodically and look for changes that are on the server or changes that are local, and then they synchronize with them. And there's quite a few issues with this, the way it works. It works. It essentially works for the users, but this really needs to be replaced. And in the long run, the goal is to rewrite really the entire feature set in Kotlin anyway for both platforms. So I'm gradually going to be replacing the way things are written in Objective-C and Swift with Kotlin, maybe even as far up into the UI. I'm not currently planning on using Compose multi-platform. In fact, I experimented with it a while back there, you can see. It's been a while since I tried it, probably 6 months, so it may be in a better state, but I'm not so keen to going with it. But the core features of the app and the logic of the app are eventually all of this code in Objective-C and Swift, except maybe for the final UI, is going to go away and be replaced by Kotlin code on this side. And those of you who haven't seen it, I may do a little summary. You know, I'm not going to do that in this video, so I may follow up in the video. I'll explain more of the logic in this. There's a previous video that we went back. Actually, it was the last video. I gave a little bit of an overview in the beginning. You can watch that, and I talk a little bit about the structure of the app. I don't really want to repeat that process here. So, if somebody puts a comment in there and requests something about giving an overview, at the end of this whole task, I plan on doing a nicely produced video where I go through, rather than just kind of off-the-cuff explanation that I'm giving you now, the overview of this project and its architecture and the rationale between doing this in a functional way versus the typical object-oriented programming in Kotlin or object-oriented programming in Swift. All right, so the problem here is the synchronization. So looking at this, I was thinking, I'm going to rewrite this on the Android side anyway. And in order to do that, I have to deal with the fact that the things that are being synchronized, specifically these line sets, so there's two domain objects, domain data, if it were. In a functional sense, we don't think of them as objects, we just think of them as data structures. But in the domain of the user, you have a line set, and a line set has a collection of lines. These are actually called line scenes because they are structurally the same as doing a scene without it being attached to a line set. So you can create, here we have my scripts. These are your scripts. And for any of your scripts, you can create scenes that aren't part of a line set. They're straight up scenes. The same sort of thing. You can record the entire script. So for the most part, scenes and line scenes are kind of identical. The difference is that the line scenes belong to a line set. I didn't want to go into the intricacies too much of it. But the point is, in the process of porting this to Android, I looked at this and realized, well, all these domain objects are written using Swift or Objective-C's core data. So you can see there's both an Objective-C side and there's a Swift side. In fact, most of the objects are primarily defined in Objective-C. So here we have scripts, and all the things that go with that. We have scenes. There's a few other things, comments, bookmarks, highlights. There's a lot of support for marking up the scripts. That's what these all have to do with. And then there's kind of add-on stuff on the Swift side. So one of the difficulties in working with this project is it's a hybrid of Objective-C and Swift. And we have yet a third language being introduced in the case of Kotlin, which I intend to replace most, if not all, of the Objective-C code and then the Swift code over time, but that's going to take quite a while. It's a large app. It has a lot of features. There's a lot of code here. I've gone through and reorganized at least the files and the folders so that it's a little easier to track. This stuff was more of a typical project where things were kind of randomly smattered through different categories. I have this organized completely, and I think I went over this already, so I don't really want to repeat this, but I put everything in the source folder. All the new code I'm writing is under main because I use a functional programming approach here where I'm not creating new classes. I'm creating standalone functions and data structures. I always separate my source from the top between what are pure functions and what are side effect functions. And we can see that also on the Kotlin side. So ideally, I want as much of the code to be in common from a KMM standpoint because I want it to be platform independent, right? This is the way these projects are typically organized. For a given app, there are three major component areas. I can't say module because this is the shared module, and the shared module is actually broken into three pieces. The common code, which is ideally where you'd like most of this stuff to be. And then there is still platform-specific code for iOS and platform-specific code for Android. And then the Android app code itself, the main code is up here under its main. It's a little confusing. Actually, I moved all that down to here. So, for example, the main activity, which you would think of in an Android app, tried to cut this down to the absolute minimum, and this is using Jetpack Compose for this side. I don't have the I don't have the UI fully implemented on this. I kind of have this kind of skeleton UI in Compose just for the top level entries, and it's got none of the graphics and stuff like that. It's not really that functional, but it's kind of a placeholder just so the app will build. Because right now what I've been doing is using the shared code primarily to support new features on the iOS side. So I've kind of been building up the Android project from the guts outward rather than from the skin inward. There really isn't much of a skin here. In fact, if I build this, you'll see the skin's kind of a joke. It's going to build the app, hopefully quickly enough. You see main activity. Wow, usually it fires up a lot faster than that. There we go. Oh, it's because it's running on my phone. My phone's plugged in. I don't want you to see my phone, sorry. There's a couple frames there, but yeah, it's just anybody's typical phone. Running in the emulator is a lot faster. Yeah, you can see. So there's not much here. It's just kind of an outer placeholder just so the app can kind of hold the guts that are being shared by the iOS side. I actually rewrote a lot of the login stuff, and the control flow logic of the login is now in Kotlin even for the iOS side. So even though iOS is presenting views and UI that still, when you log in, that still come up in iOS, the actual flow, the app flow, is now on this side. In fact, it's under app flow. So let's stop this. Again, I'm kind of jumping all over the place, so bear with me on this if you're interested. So the main app actually enters into here, and this is the guts of the app now on the iOS side as well as on the Android side. And these are all standalone functions, as you can see. None of these are methods on any class. So really kind of pushing the whole FP approach, which is the title of this, FP Mobile. And this is a proof of concept, which proves it in my mind, but we'll see if it improves it in other people's minds, that you can do functional programming in Kotlin and in Swift because they both support it. It's not the idiomatic way to do their code, but it does support it enough that you can get away with quite a few things. Even though the frameworks themselves are OO, it doesn't mean all of your code has to be OO. And that's kind of what I'm proving here. And at least we've got some stuff over here on the pure side. These functions are all pure. These data structures, well, are there data structures over here? Well, yeah, there's a data class. Kotlin doesn't really have a true structure. Swift has a true structure. And in fact, on the Swift side, I do believe anything I've made here have been made as structures. Okay, so there are some objects. This is a bridge to Objective-C. There's a reason for that. Function, function, function. Do I have any structs over here? No, I don't have any structs. These are all just functions, but they're all pure functions. They have no side effects. Yeah, because this is a, well, could I say it's not a side effect? Well, it delegates to the pure functions on the Kotlin side. So as far as I'm concerned, it's pure. All right, so back to the task at hand. Line sets, line scenes, scroll pauses. Originally, I was going to work with moving the core data classes from being based in Objective-C with some augmentation in Swift. Let's take a look at the Swift side. These are mostly like extensions. In fact, I was looking at that today on scene. There's an extension here. It's kind of awkward. So it's mostly an Objective-C class, but you can see a class method added here, points added here. And I was going to go with SQLDelight, and I was going to do the whole SQL thing. And then I put some thought into it and realized, why we're using a relational database and an ORM at all for this? It really isn't necessary, and it's really kind of overkill. And we can see in the legacy code how much code there is to support the ORM. I mean, it is big. The ORM is supposed to actually make it easier to persist domain objects, but it sits on top of SQLite, and it tries to map relational storage to in-memory object relationships and pointers and aggregations and all those sorts of things. It's the typical impedance mismatch between data storage, at least in a relational format, and object, hierarchies of objects in memory. And this is all just to support that. Now, the funny thing is, when the data is actually persistent on the back end, it's sent back and forth to the back end in the form of JSON. So when you fire up, if you delete everything off your, let me just delete all local files. So I just deleted everything off my local thing here. So I don't even have the latest. This is by the way, my breaker box. It's a diagnostic thing. Users don't have that. Generate fake scripts, purge fake scripts, clear permissions. They obviously don't have the ability to do any of that. But I'm going to restart. This will go and now fetch all the information on my account from the back end. And that's what's going to be happening in the back end with the synchronizer. So we can see this is a collection of all the scripts I have on the server. None of them are downloaded. That's what these clouds represent. But when I go to download this, right, so there's no script locally here. When I go to download this, it's going to receive two things. It's going to receive JSON from the back end, which is effectively the metadata, because the main data here is a script, which is a PDF file. It's binary. This doesn't get stored in the database anyway. This is stored as a separate file. All that goes into the database is the metadata that describes this. But that metadata comes down as JSON. It gets converted to these in-memory objects like, whoa, I didn't mean to do that. Control Z. Wow, I can't undo. I just did an accidental drag. Can I undo it? No, I just moved something. I moved this accidentally, and it's not tied into the undo system. Let's see what that actually does here. Okay, I think I fixed it, because otherwise it would, yeah. If you actually move stuff around, it's going to change the Xcode project file, and that would show up in the diff. Actually, yeah. I do a get status. Yeah, okay, nothing changed because I moved it back. So Back to the app. Stopped it, starting it again in the emulator on iOS. Okay, so, right, so the script is not stored in the database. It's a PDF file. The audio files are audio files. They are not stored in the database. There's even video in here. That's not stored in the database. So the actual bulk of the data is media. It's binary. It's not informational data in that sense. I mean, there's information. Obviously, there's information in the script. You can think of audio as information, but it's not numbers and characters. It's not the sort of thing you see in a class definition. For example, if we look at script, let's look at the script core data properties, right? So this is all metadata. This is all descriptive things about the script, but it's not the script itself. And this doesn't account for that much of the data, certainly not in terms of storage and byteage. The media is going to take up a lot more. This is coming down already in the form of JSON. And there's somewhere in here, there's a mapping to, JSON comes down and it looks for these names in the JSON, and then it shoves this into shoves it into a core data object in memory, which then you've got to go through this whole rigmarole to get that into the database. Well, I realized I'm getting it as JSON anyway. Why don't I just use it as JSON? Why don't I just take the JSON and just stringify it and put it in a file? That eliminates the whole need for SQLite or core data or that. It takes out a really big piece of technology that complicates the app if it doesn't need it. But I'm not saying that the original developers were wrong for using it. They just follow the standard practice. The standard practice is, well, you create objects in memory that are structures. I mean, that's essentially what we're looking at here. We look at scene, for example. It's a structure. Yeah, it's an Objective-C, but it's an interface with properties, but it's equivalent to a structure, C++ class, right? In-memory representation of information. This is standard practice, and then of course you've got to persist it. How are you going to do that? Well, Apple gives you core data. They've had it since Objective-C. They continue it on in Swift. If we're on the Android side and we're going to go with the Google Android recommended practices, well, it's probably going to be Room, right? It's going to be some completely different technology. It's probably sitting on top of SQLite. Because SQLite just seems to show up in all the operating systems, on the mobile operating systems. It's there, and they make use of it. So it's standard practice. But a lot of rigmarole has to happen. There's a lot of complexity there. There's a lot of dependencies that come in. And then look at all the stuff that gets generated. It's a mess, and it's unnecessary. And I realized that I could just treat the objects as the original JSON that they come down as. And that's what we're looking at here. So instead of having a line set class or a data class that's a line set, or a struct that's a line set, or an Objective-C line set. In fact, I'll show you the original ones. They have now been moved into the dead folder. So this is all dead code. Some of this code was here as I went through the project. I actually found files that weren't needed and I moved them in here. But I recently, as part of this task, moved all of these files, line scene and line set, are now dead. Because all of this code, right, is being replaced by simply treating this as, well, not JSON per se, because what happens is actually it comes down as JSON, but the networking library on here, the Alamo framework, automatically converts it to a dictionary, which is just a collection name-value pairs, which is just what JSON is. It's a hierarchy of name-value pairs. And it automatically turns it into, in Objective-C, an NS dictionary, in Swift, a Swift dictionary. And if you've been watching, you've seen that. Oh, by the way, this is the recent thing I've been dealing with, the scroll pause. So there's actually 3 domain objects that I've moved over here that I've eliminated as core data: line scene, line set, and scroll pause. Now, to try to do this incrementally and without breaking too much, I decided to only move out of core data these classes for this particular task that I needed. So line sets, line scenes, and it turned out I had to do scroll pauses because the line scenes contain the scroll pauses. So it's a hierarchy, right? It's an aggregate hierarchy, parent-child relationship. Scroll pauses belong to the line scenes belong to the line sets, and the line sets belong to the scripts. But I didn't want to have to completely rewrite the way all the script thing was being done. Sorry for flipping around so fast if it's chaotic. So this stays as an object, and what used to be its line sets as a relationship to core data is now just simply the dictionaries, which is a converted JSON. Dictionary is just a in-memory representation of the JSON. And again, I don't even have to parse the JSON. That's taken care of by the network framework. So that's for the most part transparent. And here we can see, can we actually look at the JSON originally? Let's go back to DAD folder. Let's take a look at line scene JSON. So these are the actual keys in the dictionary. These are the actual keys in the JSON that match all of the properties of a line scene. All right, so we look at core data properties for line scene. Well, there we go. Now, some of this stuff is local, is not remote. It's really kind of local synchronization state. You can see synced and in-memory stuff. But the essential information, the essential metadata here is all represented in the JSON. And there you can see this is where, mapping a JSON to an ORM simply goes from here. It says take these keys, find those things in these dictionaries, and shove them into these properties, and then store that in the database. Well, why do that? Just keep the JSON. Just keep the dictionary in this case. It's a dictionary. You can see it right there. Actually, this one makes a mutable dictionary. Here we go, NS dictionary. So it's funny, it says create from JSON. This is really create from dictionary. This dictionary was automatically created by the network manager that goes out and does the actual post call. And it comes back, the response that comes back is in the form of a dictionary, automatically converted. So what I'm doing instead is I'm just taking that and just writing it to a file and just keeping the file around. And then to actually get at the properties, I just make functions that act on the dictionary directly. That's what we're seeing here. Give me the scene audio file name. Oh, look, it's stored as this key. If it's not found, you get that. That's stored as that key. And I simply copied, right, from the legacy Objective-C, so I know what the keys are. And I'm only making the functions that are needed, right? As I need a property, I write a function. This is pure. There's no side effects. Takes an input dictionary, produces a value. And that's what we're seeing here. And so far, other than algorithmic logic, this is all the code that's needed to deal with getting the properties. That's it. Not all of this. All this, all this, all this, all this, all this, all this, all this. I mean, there's a little more in terms of reading and writing from a file, but I've been able to generalize that because these are all the same types. These domain objects are not statically typed, right? Because they're not statically typed anyway. They're not coming over the wire as static types. They're coming over a wire as name-value pairs in the form of JSON. So the object's only as good as it's coming from the back end. If the back end is corrupted, the object's going to be corrupted anyway. There's nothing on this side that's going to guarantee statically, that I have the right types and the right names in the right places. If it doesn't match what's coming in the back end, it's garbage in, garbage out, right? This is going to, where was it? Here we go, JSON. I mean, it's creating the in-memory from what it gets out of the JSON. So if this is no good, none of this is going to be good. This doesn't bias anything. You could make the argument that, oh, well, creating a line set on the app side, it's going to be using this statically typed types directly. It's not dealing with just a stringified JSON. Yeah, but all this has to then get marshaled back into JSON to send to the back end. So again, yeah, it just doesn't justify it to me. The complexity and the overhead that it adds doesn't justify it. We're going to find out because I'm in the middle of this experiment. I don't feel like it's an experiment, but who knows? Maybe I'll run into some dead end. But so far it's been going pretty smoothly and I like it. And this is all the code that I've had to write so far. Still have quite a bit to go. There's still a lot of to-dos. So this is for anybody watching. Obviously, this is not helping me on my next task. We'll go back. Again, I'm going to do the polished video and then it'll all be presented in a much more professional, clear, and digestible way. So let's take a look at what I've done, what I've dealt with. The last time we ran this, in fact, let's just stop this, minimize that. I'm going to, this is a summary of what I did today over the course of about 3 hours. And I have 2 save points. So really where the code was at was here. So I'm going to check that out. I'm just going to return us to where we were before today's task. And I can do the same thing on the Android side. I think I made only 1 save point for today. Yeah, there it is. Okay, so I can do a get checkout head 1. Okay, so now we're here. I need to recompile this. This is with the old code. Because the Android Kotlin code has to match whatever changes on the iOS side. And let's run this. I had some fun struggles today. I'm being sarcastic. It was not fun. This was not a fun day of programming. Grappling with issues in Xcode and iOS. Well, not iOS specifically. I would say the Swift to Objective-C bridge was very painful, and then even stuff on the Android side was painful, and I don't know if I'm going to revisit that. All right, so before today's task, since the last video, we were able to go into here. We go into the script. We go into the line set. We pick a line set out. Let's say line 4. We play it, and it crashes. And why did it crash? If we look at the stack, where we're coming from, we get as far as trying to play. It goes out and it says line scene. This is the scroll pauses. So the scroll pauses have been effectively converted over to dictionary format, no longer core data. They are now reading and writing from files. So we should have a set of scroll pauses. And we have a problem here. And we're not sure why. There's not a lot to tell us what's going on here. Is it do we have a null exception? Something failing? As it turns out, what's happening is it cannot find this method on the delegate object of this line scene player view. And line scene player view defines a delegate interface. So these warnings are interesting. This is part of the problem. But I'm going to show you where the real problem was. I didn't find out that this was the real problem to the end. I actually was dealing with something else entirely. But the real problem here was, we don't need this anymore. So I'm going to close this stuff down. Conversion, fake script, beat markers. Maybe it's just easier to, well, yeah, I don't need that. I don't need that. Scene flags. No, there's nothing in here that matters. Scene functions. Yeah, we're going to need this because we're going to be referring to the points here. Core properties for script. We don't need this. We don't need. Sorry, I obviously opened a lot of files in my explanation here. Scene, I don't think we need that. Line scene, no, that's dead. Everything line scene is dead. This is all in the dead folder, right? God, look at everything I opened. Okay, line scene player view, this is important. And script controller, this is important. All right. So the problem here is that line scene player view, the header file for where our crash is occurring in here, right? Yes, in this method, audio player setup scene with scroll position. Blows its brains out right here. It's trying to call an object that is the delegate for certain operations here. And here's the delegate interface that line scene player view says. Right? And the idea is that a delegate is some other object is responsible for certain things that this object wants to do. So in this case, it wants to set up the scene with a scroll position, and it's saying, you know, the player doesn't know how to do that. It's going to delegate to this function that's part of that it defines here, and the delegate's going to do it. And who is the delegate? We're going to look at the delegate here, right? Let's see who the delegate is. We go to the very top where the delegate is initialized. Sorry, I'm not doing a good job of where is it? Let's just go to the top. Somewhere in this initialization, the delegate. Delegate self, initializer. Where does a delegate get created? Why am I having a hard time finding this? Let's try this again. Self delegate. Okay, where do I get? There it is. Setup on view. Yeah, it's not as obvious, right? One of those view classes. And the delegate being called up in here, we don't know, right? This is dynamic dispatch. So at this point in the stack, we don't really know who the delegate is, but it turns out the delegate is the script controller. And you can see right there, it implements this protocol, which is the protocol required by line scene player view as the delegate protocol. So this is a script controller, this guy. And why does this matter? Because, see these warnings? These warnings are the problem. And in fact, let's recompile this so you can see these warnings highlighted in yellow. They're not showing me the warnings. Well, that's funny. They were just there, and now they're not highlighted. Probably because it didn't have to recompile. Here it is down here. Yeah, these are the ones we care about. Let me just, I'll just put something. Actually, I don't know if doing and undoing is going to cause it to recompile. I don't know if that's going to touch the file. It should, but we should, there we go. There's the warnings. Okay. This is a pretty nasty problem, and I spent quite a while chasing this down. And for those of you interested in Kotlin and Android, sorry, we're purely in Swift land right now, Swift Objective-C land. This instance method, line scene player scroll, nearly matches the optional requirement of the protocol. So if we go back and we look at the protocol, for starters, it doesn't quite have the same name. So that's a little bit of a problem. But for some reason, it is able to match up. Now, this one has the same name, line scene player setup scene. But if we go and we look at script controller, line scene player setup scene, we're also getting the same error. It's saying, look, it nearly matches this optional requirement. Notice the optional part. This is a key thing that allowed me to fix it. For some reason, the original author of this, when he made the delegate protocol, he said, I'm going to make these optional. Not sure why he did that. Doesn't make sense to me. Obviously, this is not optional. It's obviously required by a significant part of the app, right? Here, this delegates to it. So if somebody's going to pass in a delegate, why make it optional? This is a large part of the problem, this optional thing right here. Because what this is saying is it's saying, look, it's optional. You don't have to provide this method because the delegate protocol declared it as optional. But I'm going to try to match it up, and it's not quite matching. It says, look at this, line scene. Now remember, line scene used to be this core data object, and it got replaced with this dictionary. And this whole thing with the exclamation points and the optional was really throwing me off, something I didn't really know about Swift. I understand that the question mark is the optional. What I didn't realize was that the exclamation point is also turns this into an optional, but as an added benefit, it automatically unwraps when you reference it, meaning you don't have to say if let, if it's not null, then I can reference it. I can effectively unwrap the optional. That does it for you automatically. And if the optional, if it turns out to be nil, you just end up crashing in your code. And this exclamation point, which in my opinion should never be in the language, sorry, but you should force people to deal with wrapping and unwrapping. I know you have to wrap and unwrap in Rust. I haven't done a lot of Rust recently. They've made a lot of changes to the language. Possibly they added something like this. I'm thinking they probably didn't. This would be considered pretty unsafe. Swift's just like, yeah, let's just let them be unsafe. No problem. And this, I didn't even notice this, really. And I thought this was a large source of the problem, but it wasn't, because the line scene being passed in is not nil. So that's not causing the problem here. What's causing the problem is it says, look, I'm looking for this line scene player setup scene. That's what we've got here. But it doesn't quite match. It doesn't quite match. Well, line scene is an optional NS dictionary. Now, here's the problem. This is the bridge between Objective-C and Swift. This is a Swift extension, right? It's an extension on Script Controller. So Script Controller itself might be entirely Swift. I don't think, it doesn't matter. The point is that the delegate is defined in Objective-C. So this is an Objective-C protocol, which then gets mapped to this Swift implementer of this protocol. So here's what the method looks like there. Here's what it looks like here. A little bit different, right? Void return type, no return type. Okay, we have no return type. And this is the same as you can see in the message here, right? We've got a right arrow to unit, or they don't call it unit here. They call it unit in Kotlin. We went over that in one of the other videos. What do they call it? It's an empty tuple. That's an empty tuple. That's what void is. Void is an empty tuple because as it turns out, even void functions in Swift always return something. In this case, the void ones return the empty tuple, which is implied if you don't have the return type here. It's important to know because it's not quite the same as unit on the Kotlin side, or maybe it is. It has identical syntax, which is what's funny about it. But back to this. So we're void. We have no return type or empty tuple. Our argument is line scene reference, not a pointer, but a reference. Line scene has been type deft. Now it's not type deft in here, which are like, why is this able to refer to line scene if it's not in here? Well, this is the nastiness of this header gets pulled in actually after other headers come in. So there's a global header that pulls in the things that it needs to see. It's a mess. I don't even want to go down that. I was chasing that down a rabbit hole. And I actually put the line set definitions in here to clear it up. But if we look at line scene, what is line scene? Jump to definition, not going to work. Xcode does not want to help you if you're in Objective-C. You just get no help at all. Or I just don't know how to use it properly for Objective-C, but it's extremely painful when half of this application is written in Objective-C. But I know where this line scene has been type deft. So originally it was a class. You can see the class is commented out here. And instead, because line scenes and line sets belong to scripts, it's been type deft inside the script declaration, where it mainly gets used. I believe it's here. There we go. Type def. So it's now merely a dictionary. They used to be classes. Line set, line scene used to be classes, but now they are just type deft as in its dictionary. Well, in its dictionary isn't that compatible with dictionary? Isn't that what we saw when we went over here? Doesn't it say optional in its dictionary? Okay, line scene. That looks right in its dictionary. So I was chasing down. I couldn't figure out if there was a problem with the compatibility because the Swift dictionary isn't quite the same. And I was going round and round on that. But that wasn't the problem. And I couldn't discover the problem. I tried a bunch of different things. There's this weird thing where it will try to take, and it was something about some version of Swift. I was reading on Stack Overflow as I was trying to chase this down. Other people run into this problem a lot, apparently. That these named arguments, they get mangled. That's what we used to call it in C++, name mangling. But a name gets added on the Swift side to something like this. Because of the difference between the Objective-C method syntax and the Swift method syntax, in their infinite wisdom, the designers of Swift made another bad decision. Yeah, I'm saying it, and I'm not holding back. This is bad language design. There's some good things in Swift. There's a lot of not good things in Swift. You can tell it's not my favorite language. Kotlin's not my favorite language either, but I think I will take it over Swift. One thing Swift does have is it does have, in some ways, a little bit better support for some of the functional features. Kotlin's much better in its conciseness. Much less boilerplate is needed. Still a lot of boilerplate needed on the Swift side. Anyway, aside from that. So we see that we have a Dennis dictionary, line scene player view. Wow, this video is going on longer than I expected, but at least I'm explaining things rather than just struggling through them. So if you're still interested in still watching. So as it turns out, how I fixed the problem is I got rid of the optional. Because it doesn't fix the problem, it helped me identify the problem. Because right here, we're just getting, where was it? Not scene functions. Sorry, I didn't want to be there. I always get lost amongst this stuff. Script controller. Do we need audio player? I don't think we need that. Too many things up here. Script core data. We don't need to see this, but we can see this in its dictionary. Script functions. Oh, okay. So I have two type defs, right? I have one on the Swift side because they don't see each other. This type alias line scene. And here it's type defs. But you can see it's the same type. In its dictionary and its dictionary. All right. Script controller. We come down here. These are only warnings. So it doesn't match up, which means it does not map, it does not connect, does not use this method as available for the actual delegate. So what ends up happening is there's no method when it makes the call, and that's what the crash is happening. In Objective-C, because it's really dynamically typed, you can call a method on any object, whether that method has actually been defined on that object, and it won't throw an error until runtime because it's effectively a message call. This is like Smalltalk, a different paradigm or different approach to object orientation than statically typed, statically bound types and dependencies. So struggling and struggling, and I couldn't figure it out. I'm just like, you know what, let's just get rid of the optional. If we get rid of the optional and we compile it, now we're going to have a problem because these are now required, and that warning becomes an error. Well, it should be an error. Exactly. Now we have an error. It does not conform. It's actually telling us. Where is it? Has non-matching type. So what used to be a warning is now an error. Right here. Line scene player setup scene. It's like it's required and this isn't doing it. Well, as it turns out, if we do this, because the AutoMagic translation of this is to take line scene, which you can see is in camel case, in other words, first letter is lowercase, and append it to the name of the method that it expects to see in Swift if you're using Swift, right? So if the delegate here, if this implementation was in Objective-C, it would be fine, but it's not in Objective-C, it's in Swift. And in their wisdom, they decided, well, that's really going to be nice. We're going to say with line scene. I don't know what the rationale is, and I'm not going to even bother to chase it down. But if we do that, it ends up working. But we still have other ones that don't work. Line scene, player start scene, any hashable, any. Oh, and the types became a problem. So it's a combination of both. It's both this and the types. So I'm going to actually, we see what the problem is. I'm going to show you what the fix is. I'm not going to retype all that. It's going to take forever. So let's go ahead and just reinstate where the fixes are. And I'll just walk through the changes. Our latest branch, so we have a detached head, meaning we just checked out without using branch name. We just bumped ourselves back down. And we're just going to get back to where we were. It's line scene, line set as JSON. Okay. Oh, I think we made some changes to code here. Yeah, we don't need those. Stash. All right. Ah, there's the difference. So, was it the with scene thing? Am I completely off base? I don't see the with scene thing here. It wasn't the with scene thing. I was chasing the with scene thing. Apparently, if you put this underscore, it eliminates that need. The problem was the type def. Huh. Okay, never mind. Maybe I have to redo this video. And here, over here, we're on dev domain D. Well, I don't mind making big blunders in public. I have no shame. Shame is a wasted emotion. Let's rebuild this. Okay, rebuilt. We're back up to where we were. And compile. Yes, any hashable, any problem. Wow, I could have swore I fixed it by changing the name. But it was a type problem. Okay, so now when we actually go to do this, we go to line sets. Doesn't crash. And we can actually play the line.
Hemorrhaging around the heart.
Hemorrhaging around the heart. All right. So we got through that. Well, that was a long-winded accusation of trouble that really wasn't the same problem. But, right. So you can see the fix here. And I put lots of egregious comments in here. Besides, this code is, I'm planning on this code going away. I need to look at this though, definitely. Oh, that's because I've got the to-dos in here. I have stuff that still needs to be rewritten. But this stuff down below didn't need to be written. But the comment was a nightmare warning when optional. Remember, I did get rid of the optional. Not really optional creates a nightmare Swift warnings, which is what was happening here. Right? So I got rid of the optional. And in the script controller, the difference here is I had to put in Swift's actual dictionary type, which is what this is, instead of the line scene, which I actually added a type def. Did I add a type def somewhere in here? I changed the type defs. No, that one's the same. Here, this was solving another problem. So let's do a get show head 1. Yeah. Originally, scroll pause, we were having type problems where it couldn't just take a generic, a non-generic, well, yeah, generic, in this case, dictionary without specifying its actual key value types, which is what you've got here, string and ID. And going to the default dictionary was causing a problem. So I added these generic type specifiers, and this made it compatible with that. But for some reason, using line scene here under Swift, see it says NS dictionary. And if instead I copy these over, it doesn't work. In fact, you can't really do that, right? So NS dictionary, NS string ID, but on the script side, you've got to say it's an NS dictionary. And in fact, I don't believe I can actually just do this. You would think this would be the solution. I wonder if I can do that. Maybe that solves the problem. Because this is what it effectively is. But this Swift dictionary, it's not quite the same as the other one. I'm starting to realize here. Let's see what happens when I do that. Yeah, I run into this problem. This becomes a mess. I thought I solved this problem some other way. Yeah, line set to hashable. This just becomes a mess. This bridging between Objective-C and Swift is really painful. This isn't the only place this problem occurs if I do that. So let's go back to this here. I have to say NS dictionary here, and I can't quite put in this. This doesn't work. Let's back up. Right? If I try to instantiate the template style, right, there's no star to start with, and ID is effectively the same as any. I don't think it likes this. Yeah. It doesn't see NS dictionary as a generic type on the Swift side, but it sees it as a generic type from this side. So apparently this NS dictionary, not quite the same as this NS dictionary. But what sucks is that this type alias is not effective in here. Where was it? I actually have to change this to string any in order for this declaration to match. There was a problem with the name, by the way. This one didn't include scene. This one had to include scene because that's the way it was specified over here. But if you see this line scene, right, this line scene is declared as that. Oh, by the way, I added these types in here. It's kind of seems like it's redundant with that. I don't know that I even needed to do that. Let's see if I get rid of that. Because it was okay with the way it was before. That might be redundant. No, looks like it's needed. No, looks like it's okay. I don't need that to be in there. Don't like having redundancies that I don't need. Let's make sure this works. Yeah, it works.
Hemorrhaging around the heart.
Hemorrhaging around the heart. Yeah, I don't need these. Let's get rid of it. It's already picking it up from here. I don't really want to have it redundant. So I'll go ahead and I'll add that as well. But back to the script controller problem. So I don't like these spaces. I had to use this declaration to get it to match, even though the plain NS dictionary declaration here, right, worked. Or did not work, right? This is line scene. And in fact, if you go into the script controller, and in fact, let's do this again. This was the original, and this is what I had to replace it with. Now it's going to find that whoops, whoa. What happened? Oh, look at that. What's going on? What did I accidentally change something else? Ooh. Oh, yeah. I tweaked that. It's just stray keystrokes. Okay, I just took that out. And I got rid of spaces there. Okay, let's try again. Confusing myself here. Right, so it doesn't conform. Doesn't like it's missing. It says it's missing this guy. Where was it? Where was it? This guy. Right, if I say line scene. So I have to specify that. But if I change, God, just press any key on this keyboard. If I change this, line scene, let's try this again. That's Swift. String any. All right, let's try this again. I'm going to run into that other problem. Yeah, it still doesn't work. It still doesn't like it. So this doesn't help. These are all, it's weird how it keeps these old messages in that are like no longer applicable. It's just strange. But that didn't solve the problem. Line scene, string any, right? Requires a function with type, string any question mark, void. Let me look at it one more time. I'm not going to belabor this because the other solution works. And again, this is code that's going to go away. I don't need to make it perfect. Stop doing what you're doing. Where are we? Script controller. Okay. Yeah, it doesn't like Wonder if I make it a question mark. It says question mark. No, see, it still doesn't see it. Wait. Oh, it doesn't say seen. Wait, maybe that's the problem. That was a problem originally, that it didn't say seen. All right, let's see if that solves the problem. Yeah, that works. So it does work. Huh. So I didn't need to do any of this. What? I could have just changed these definitions here. If I go line set, I get a problem with the other. So if I could do line string any, I run into this problem. That line set, we jump to definition. That's what we're looking at, line set here, without saying in its dictionary. Problem is, it doesn't end up matching script, core data properties. Or is it here? Right, line set is an NS dictionary, NS string. And line sets here, this set of line sets, it's a set of that. This should match that Swift dictionary, but where was the error? Show me the error, show me the error, show me the error. It's not able to do this. Line sets, as set of line sets, doesn't think it matches in this case. Requirement from conditional conformance of line set to hashable. Any is hashable. It's not conformed protocol hashable. Why does it care? This set line set, we're in Swift. We're saying, give me the line sets, set line set. You can see that in script. Not there. Not there. Here. Right? Set of line set. Reference to a set of line sets. It looks like that. It has to look like this or it won't match elsewhere. And if we go and we say that should be equivalent to this because that works for line seen, but it's going, nope, nope, I can't do it. Wonder if I need the as. Maybe I don't need the as in there. Can I do that? Still, same problem. Set any hashable. This is a function. That's the problem. That's why I need the as. This is not a member, it's not a property. This is a function on script. Well, you probably don't want to be bothered with this. I'll chase this down and figure it out. I don't need to drag this video out. But yeah, you can see this is a method call. But this is what it returns. Returns a reference to an NS set versus set. Maybe it's the NS set that's the problem. See, I got the same thing though. I can't say NS set. I think I tried that once. It didn't like it. I think that's going to be no-go. Yeah, there's that non-specialized type. So NS set is generic in Objective-C, but it's not generic on the Swift side. You got to make the Swift equivalent. And it can't do it. Set requires that any conform to hashable. And NS dictionary is hashable, but the other dictionary is not, apparently. Right, so I can do this. There's probably a fix. I just don't know what it is. What if I do this? Wait, let's try. Maybe I can fix it just in this case. No, NS dictionary. And keep it defined that way for everything else. See, look at that. Dictionary string any and NS dictionary to be equivalent. As. Why do I need the as? Oh, I'm sorry. I'm dragging this on. This is what I wanted not to do, was to do raw programming in this video. Instance of a class or class constrained type. Maybe it has something to do with this array initialization. Why does this need to be a type? It needs to be an instance of a class. This is not an instance of a class. It returns an instance of a class. Script, self, dot. No, that doesn't solve the problem. All right, this yeah, let's just stick with what this is. But this has to be in this dictionary. But the other one, it seems like I can do that. Let's put a note in here. I mean, again, line set cannot be string any or compile error below. I don't want breakpoints. Stop that. I'm just going to say for now. Actually, maybe resolvable. But again, do we care? The reason I want to do this is I'm going to keep it like this. I'm curious, but I'm not going to change the other thing. Keep the rewrite the way I had it. So let's keep these intact. I prefer not to use line seen as its own type anyway. I prefer to replace that with a specific dictionary type. I don't like type aliasing this. I have a new take on that, type aliasing. All right, I think we're going to wrap this up. I just want to see if there's one other thing on the Android side, Kotlin. If you're still watching and interested, take a look at that. But that's fundamentally the issues on this side. And again, let's just test this really quick. This wasn't much of a summary, was it? Sorry about that.
Hemorrhaging around the heart.
Hemorrhaging around the heart. Okay. Done with done with that. I don't think there's really much more to show here in the changes that we did. So we saw that we didn't need that. We pulled that out. Dictionary. Yeah, pretty much these fixes. That's it. And then there was a previous change to that, which I showed you that. I had to make that, yeah, the specific generic signature. Did I discuss this in the previous video? I must have. I think I just didn't save it. This was that whole thing about getting this initialized. So yeah, I think we're fine. Yeah. There's nothing more to show you on this side. Dictionary. Yeah, we saw all that. We saw all this before. I'm going to go ahead. Let's see. I'm going to save these current changes. Yeah, I didn't need that, so I got rid of it. So that's line scene player view. It's the header, right? Oh yeah, extra space. Okay, got rid of that thing I didn't need. This is interesting. Maybe resolvable, yeah. And what happened here? Oh, did I put a question mark in there? Oh, I think I got rid of but I put a question mark in there. Not quite what we were looking for. Func line scene, start. Okay. Yeah, I don't want to confuse myself. Let's make this match what it was before. Actually, I don't mind getting rid of the spaces, but yeah. That and that and get diff. Yeah, so here we just collapse the spaces on that. Other than that, it's the same. Okay. Get a dot, get log. We're just going to whip save point this. Whip 34, save point. Yeah, get push, get lab. Save that. Get push, get up. Let's build it one more time, just make sure we didn't screw anything up. And I'm going to show you the Kotlin stuff, and then I'm going to wrap this video. It's a little over an hour. It's an hour and a half. Well, it's half the length of the video I did earlier, and it's absent a lot of the ranting. At least I think that is. Again, this is still pretty off the cuff.
Hemorrhaging around the heart.
Yeah, we're hemorrhaging around the heart. We know. All right, let's close out iOS here. Just get out of here. And on this side, what changes did we make? I got rid of unnecessary types because there's inference here, which I like. What are we looking at? Domain replication, same. We're looking at scroll pauses. There was one significant thing in here which drove me a little crazy. I don't know that I want to repeat my rant. I went off pretty hard on Android Studio about this. But yeah, I got rid of the type specifications and let it use type inference, which I like. And yeah, you can see that. But the main fix was this right here, get or null. So I was making a call to get. I was expecting the default of get to actually be the same as get or null. And I forgot about get or null. I haven't used it on this project, but I've used it elsewhere. It's my mind, it slipped my mind, but I thought this was the same as get or null. And if you go here and you say, in fact, getting like no intelligent help here. You know what, I'm not going to repeat all that. Went down a big rabbit hole, but this was throwing in an exception. If you pass an index and the index doesn't exist, it doesn't tell you that. If we actually look at the source, can't we, Why am I getting, it's weird. I'm getting like a different, there it is. Okay. We see abstract operator get. There's no indication that there's an exception being thrown here. In fact, there's no description of what this does. If we jump to source, we see the same thing. If we look at the online help, we see the same thing, right? No indication by the language or otherwise. And this threw me for a loop, operator get. This is an override of the actual brackets operators. So whereas these are just functions, this is an operator function. And I guess you're just supposed to know that if I were to do, and the reason why I use get here is because I can't just do, I don't believe syntactically I can have period this, can I? I think it's going to like that. No. Right, so I use the get call because otherwise I'd have to give it a, I have to name the argument. I have to make it not tacit. I'd have to say let it index. Right? I'd have to do that. That's legal. And as it turns out, get is the same as that. But clearly, if you subscript, you index into a collection array, a list in this case. Strange that a list has an index operator. And it's not there, it's going to throw an exception. And the get does the same, but there's no documentation to tell you that. So I assumed that this was the equivalent of get or null, but it's not. You have to say get or null. And that's it. That's all I have to show you for now. It was a long-winded summary. We're at an hour and a half or hour 21 minutes. Appreciate you watching. This is good to refresh my brain, and I'm going to do more summaries of this in the future rather than dragging you down the full rabbit hole of my struggles with coding all this. I wish you the best of luck.